Automatic, Addison.
In this tutorial, we will explore operators and control flow structures in C++. Operators and control flow structures are essential for creating logic and making decisions in your robotics program. Let's open a terminal window right now, and we will look at an example of using mathematical operators in C++ for performing calculations in robotics projects. Let's move to CDD, CD, DDDDD. Let's go to the Documents tutorial, CPP tutorial, and let's open Visual Studio Code. Let's move that out the way. Okay, code period. Open, please. Type in my password. Okay, let's clean this up a little bit from our old work. Okay, let's start by creating a new C++ file. We will name it basic math, robot basic. Let's name it robot basic math.cpp. Robot basic robot underscore basic math.cpp. All right, here we go. Okay, and let's type the following code. All right, let's start with declaring the pound include, as we always do, IO stream, and we will do int main. Okay, and let's do int motor speed equals 100. This is our base speed. Okay, let's do int speed increment equals 20, and this will be our speed adjustment. All right, let's do addition here. Let's do int increased speed equals motor speed plus the speed increment. Now let's do subtraction. We'll do int decreased speed equals motor speed minus speed increment. Multiplication. Int double speed equals motor speed times 2. Let's do division. Int half speed equals motor speed divided by 2. Let's do the modulus, which is the remainder operator, modulus, remainder. Let's do int remainder equals motor speed modulus 30. Let's output the results. And here we go with all our stood C out. Stood C out. Let's do original speed. Okay, and let's do motor speed, stood, and L. Okay, let's do stood C out again, and let's do increased speed. Stood and L. Let's do stood C out, decreased speed. Decreased speed, stood and L. Let's do stood C out, double speed. And let's type double speed here. And then stood. Inline. What else? What else? What else? Let's do half speed. Let's get this cursor out of the way. Half speed. And let's do stood. See out. Remainder. And let's do stood and L. Okay. And as always, our return 0. Whew, that's a lot. In this program, we demonstrate the 5 basic mathematical operators. We have addition, addition. We have subtraction. We have multiplication. We have division. We have the modulus operator right here. Now let's run the code and see what we get in the output. And here we get original speed 100, increase speed 120, decrease speed 80, double speed 200, half speed 50, and the remainder is 10. These operators are essential for various calculations in robotics, from adjusting motor speeds to processing sensor data. Okay, now let's close this file out. And next, we are going to explore the use of conditional and logical operators in C++ and their relevance to robotics. Conditional and logical operators are essential for making decisions and controlling the flow of your robotics programs. Let's create a new C++ file and name it robotconditions.cpp. Robotconditions.cpp. And type the following in the code editor. Pound include IO stream int main. Double battery level equals 0.75. Now let's do bool obstacle detected equals true. Now let's do if battery level is greater than 0.5 and not obstacle detected. There's no obstacle detected. Let's do the curly braces and we will do stood. See out. Robot is moving forward. We do stood and L. Now we do, let's go down here. Okay, and let's do else if battery level is greater than 0.5. Come on, baby. And obstacle detected. Stood, see out. Robot is avoiding the obstacle. Stood. Stood and L. Okay, and let's go down here. Oh, not else of, we need else if. Okay, is all that good? Okay, and now an else statement. Let's do stood, see out. Robot is stopping due to low battery. Stood and L. Return 0. So what did we do here? In this code, we include the IO stream header for input-output operations. Inside the main function, we declare variables for battery level and obstacle detected, representing the robot's battery level and whether an obstacle is detected. We then use conditional and logical operators to make decisions based on these variables. The if statement checks if the battery level is greater than 0.5 using the greater than operator. And if no obstacle is detected using the exclamation point, okay, right there, for the logical not, okay. And then if both conditions are true, the robot moves forward. That's right there. The else statement, the else if statement checks if the battery level is greater than 0.5 and if an obstacle is detected. If both conditions are true, the robot avoids the obstacle. That's the else if statement. Okay. And then finally, the else statement is executed if none of the previous conditions are met, indicating that the robot is stopping due to low battery. So it's either moving forward if we've got enough battery and no obstacles detected. It's avoiding the obstacle if we have enough battery and an obstacle is detected. Otherwise, the robot is low battery, it's less than 0.5, and it needs to go back to the charging dock. So run the code. Robot is avoiding the obstacle. Okay, right there. And why is that the case? Well, we see 0.5 and we have 0.75 for the battery level, which is greater than 0.5. And an obstacle detected is true. So this piece of the if statement is going to execute, which means we're going to run this piece, which is robot is avoiding the obstacle. So this example demonstrates how to use conditional and logical operators in C++ to make decisions based on the robot's battery level and obstacle detection. Okay, now let's look at a concise example of using for loop in C++ for iterating in robotics projects. Let's create a new file called robotforloopshort.cpp. And type the following into the code editor, pound include iostream using namespace standard int main so int robot positions equals curly braces 0, 10, 20, 30, 40. For int I equals 0, I less than 5, I plus plus. And let's do cout robot position. And let's do this robot positions like that. And put our index for this array. And as we always do, let's just do the inline here. Let's close out this for loop, and we have to do the return 0 down here. So what are we doing? What are we doing here? In this example, we demonstrate the use of the for loop to iterate over an array of robot positions. We declare an array, robot positions, that stores the positions of a robot at different points in time. We then use a for loop right here to iterate over each position in the array. The loop starts from 0 and goes to 4 since there are 5 elements in the array. And inside the loop, we print the current robot position using cout. So let's run the code. And we've got a problem. Let's see what's going on here. int robot positions for int I equals 0, I less than 5, I plus plus, oh, semicolon. Save again. Let's run it. And here you can see the robot positions printed in the terminal. 0, then 10, then 20, then 30, and then 40, which is exactly what we have when we initialize the array. Let's explore the use of the ternary operator in C++ for making concise conditional statements in robotics projects. The ternary operator allows you to write simple if-else statements in a single line of code. So I created a file called robot_ternary_operator.cpp, and I will type the following code. Pound include iostream, and let's do using namespace std. Int main, and we'll start with int battery level. Let's set it to 75. Let's set the battery threshold to 20. Let's create a string variable to store the battery status. And now with our ternary operator, so we'll do this check battery level greater than battery threshold. Okay, and what do we want to do here? What do we want to do here? Okay, if the battery level is greater than the battery threshold, we want the value of battery status to be sufficient, the string sufficient. Otherwise, we want it to be low. And might as well print out the battery status to the terminal. Int distance to obstacle. Int safety distance 50. String action distance to obstacle less than safety distance. Okay, and so this is our other ternary operator. And what do we want to do? If the distance to obstacles less than the safety distance, let's make the value of the action to stop the robot. Otherwise, the robot needs to continue. All right, and down here, let's do cout action. And let's go over here. Action, end L. Let's do return 0. So in this example, we demonstrate the use of the ternary operator for making conditional statements. First, we check the battery level of the robot. Is the battery level of the robot greater than the battery threshold? If so, the operator will return sufficient. If not, it will return low, and it will take that result and store it in the battery status variable. Next, we check the distance to an obstacle. We compare the distance to obstacle with the safety distance using the ternary operator. If the distance to the obstacle is less than the safety distance, the ternary operator returns stop. Otherwise, it returns continue. The result is stored in the action variable. We then print the battery status and the action using cout. So let's run the code. So battery status is sufficient, which is because we have 75. And we set our safety distance to 50, but the distance to the obstacle is 30. So we need to stop the robot. Pretty cool. So you should see how the battery status and the action is printed in the terminal. So this example demonstrates how the ternary operator can be used to write concise conditional statements in C++ for robotics projects. The ternary operator has the following syntax. I'll type it in the terminal so you can see it. So it's condition, question mark, expression 1, then the colon, and then expression 2. So if the condition evaluates to true, expression 1 is executed, otherwise expression 2 is executed. The ternary operator is a convenient way to write simple if-else statements in a single line of code, making your code more readable and concise. Okay, let's clear everything out from here. Let's close this out. And let's explore the use of the while loop in C++ for iterating and repeating code blocks in robotics projects. The while loop allows you to execute a block of code repeatedly as long as a specified condition is true. So let's go over here and let's do new file, robot while loop. Nope, we have to do the CPP on the end of it. Closed out before I got a chance to add the .cpp. .cpp. Okay. Now we're in business. So let's do pound include IOStream using namespace standard. Now let's do int main. And let's do our first variable, int distance equals 0, int target distance equals 100, int step size equals 10, while distance is less than the target distance. Let's do distance, the augmented operator, which is plus equal step size. So what that means is distance is equal to distance plus step size. That's what that line means right there. But we just do the plus equal. So that's how we do as software engineers and make our lives easier. So robot moved, and let's do distance units. And let's do end L. Oh, we're missing a parentheses up here. That's why it's screaming at us. Okay. Now let's do cout. Robot reached the target distance. Let's do end L. Int count down equal 5. While, let's see, while count down is greater than 0. Cout count down so that's an end L, and let's do the count down minus decremented decrement countdown variable, and then down here let's do cout count down finished, launching the robot, then end L, and then return 0. So in this example, let's go up so we can see the code in all its glory. We demonstrate the use of the while loop for iterating and repeating code blocks. First, we simulate the movement of a robot towards a target distance. We initialize the distance variable to 0 and set the target distance to 100 units. We also define a step size of 10 units. We use a while loop to repeatedly move the robot by the step size until the distance reaches or exceeds the target distance. Inside the loop, we increment the distance by the step size and print the current distance using cout. Once the robot reaches the target distance, we print a message indicating that the target distance has been reached. Next, we demonstrate a countdown while using the while loop. We initialize the countdown variable to 5 and use a while loop to repeatedly decrement the countdown value and print it using cout. The loop continues until the countdown reaches 0. After the countdown finishes, we print a message indicating that the countdown is finished and the robot is launching. So let's run the code. There we go. 5, 4, 3, 2, 1. Countdown finish, launching the robot. This example demonstrates how the while loop can be used to iterate and repeat code blocks in C++ robotics projects. The while loop continues to execute the code block as long as the specified condition is true. It's important to ensure that the condition eventually becomes false to avoid an infinite loop. Okay, let's close this out. So now let's move on to break and continue statements. Let's look at a concise example of this. And we're going to use break and continue statements to control the flow of loops in robotics projects. So let's start by creating a new file. We're going to call it robot break continue concise.cpp. Type the following into the code editor. Pound include iostream using namespace std int main int distances equals 10, 20, 5, 30, 15. Int max distance equals 25. For int I equals 0, I less than 5, I plus plus. Let's do if distances I greater than max distance. Let's do cout. And let's do distance exceeds maximum limit. Stopping. Okay. Stopping the robot. Stop the robot. Okay, and then end L. And then we're going to go down here and type the break statement. And I'll explain that later. Now we're going to do if distances I is less than 10, cout distance too short, skipping iteration. Okay, and let's go over here and do the end L. End L. And do continue. And down here, we're going to do cout, moving robot, distances, units, end L, and return 0. And And let's run it. So in this example, we demonstrate the use of break and continue statements in a loop that controls a robot's movement based on distances. We define an array of distances that represents the distances the robot needs to move in each iteration. We also define a max distance variable to set the maximum allowable distance. We use a for loop to iterate over the distances. Inside the loop, we first check if the current distance exceeds the maximum distance. If it does, we print a message indicating the maximum distance limit is exceeded, and then we use the break statement, break, to stop the robot and exit the loop immediately. Okay? Break. Exit the loop immediately. If the distance is within the maximum limit, we then check if the distance is less than 10 units, right here. If it is, we consider the distance too short and use the continue statement to skip the current iteration and move to the next one. If the distance is within the acceptable range, we print a message indicating that the robot is moving the specified distance. Now run the code. You should see the messages related to the robot's movement and the effects of the break and continue statements printed in the terminal. This example demonstrates how the break and continue statements can be used to control the flow of a loop based on a specific conditions in robotic scenario. The break statement is used to stop the robot's movement if the distance exceeds the maximum limit, while the continue statement is used to skip iterations where the distance is too short. These statements allow you to handle different situations and make decisions within the loop, providing flexibility in controlling the robot's behavior. Okay, let's close this out. Let's now explore the usage of the do-while loop in C++ for robotics. The do-while loop is similar to the while loop, but it guarantees that the code block is executed at least once before checking the loop condition. Let's create a new file called robot-do-while-loop.cpp. robot-do-while-loop.cpp. And type the following into the code editor. #include iostream. Using namespace standard. Int main. Int count equals 0. Do cout robot iteration. Count end L. And let's do the count plus plus over here to increment. And let's do our while loop, while count less than 3. Let's do return 0. Okay, so in this example, we demonstrate the usage of the do-while loop to iterate a fixed number of times. We declare a variable count and initialize it to 0. We start the do-while loop, which begins by executing the code block inside the loop. Inside the loop, we print the current iteration number using cout and increment the count variable. After executing the code block, the loop checks the current condition of count. Okay? Count less than 3. If the condition is true, the loop continues to the next iteration. If the condition is false, the loop terminates immediately. Now let's run the code. This is what we get right here for our output. You should see the robot iterations printed in the terminal. This example demonstrates the basic usage of the do-while loop in C++ for robotics. The do-while loop is useful when you want to ensure that the code block is executed at least once, regardless of the initial condition. So in robotics projects, the do while loop can be used in scenarios where, for example, you want to perform an action or collect data at least once before checking a condition. For example, you might use a do while loop to ensure that a sensor is read at least once before checking if the reading meets a certain threshold. So that's it. Thank you, and I'll see you in the next tutorial. Keep building.